So here we are going to see advanced data frame operations in Pandas. So few of them are we have used here. Let's start. As you might already know, df.info and everything we have already seen. So here it will give us count of 9,996 entries are there, and all are non-null. So there is no null value. If we see our data, we can see date, region, product and sales. These four are the columns there. Now we are going to see all the operations, advanced operations, which we had discussed in the previous video but not covered. So the first operation which we are going to do is shift operation, and the shift operation shift the values in a column by specific number of periods. So we, if we put shift 1 here, it will give us like lag. So it is useful for lagging feature or even lead. It depends on how do we put it. So let's do it. Now if we see 837 is here, 986 is here. So the shift operation, if we put 1 here, you can put negative as well for lead. And if we put so here we have put shifted the sales column by 1. So here we can create another column and take a difference of sales of current day and previous day. So we can compare if we had many uh, if we had done any progress today. I mean, if we had made more sales today or not that. So based on that, again we can do some conclusions depending on date, and we can again utilize other functions which we had seen in the previous video, update functions and all. So basically shift operation will shift that particular column by the number of specific rows which we provide. Then there is another operation called cum sum. So that is cumulative sum. So if we want to get the cumulative sum of sales, here is how we will do it. And we are calculating cumulative sum based on product. So for each product we are calculating this. So that's why that's here is how we do it. So we will do it group by, and then we will select the columns as sales and put cum sum there. The cumulative sum will be there. So as you can see, 837 plus 986 is 1823. Then for 1823 plus 335, like that cumulative sum will be there. So for each product we are calculating this sales. So if we again do product, then group by date, if we calculate month out of it, then for each month we can do cumulative sum. So entire month how much sales we got and all. So basically this is how cumulative sum works. Now if you see df.index, so the index is integer 64 index for the data frame, so 0 to 9986. There is another thing called multi-indexing, so it will allow us to have multiple levels of indexing, and here we are putting on the region, product and date. Now our index is changed. So multi-indexing is useful in few of operations where let's say stacking is there. So yes, in stacking also, so there are two more operations, stack and unstack. So stack will compress multiple columns into a single column, and it will, that will make sure, so it will reshape the data frame from wide to long format. That means it will be like from here it is like this. So after we do it, we can see this is a single column. If we run this, and we can see pandas core series. So this is series because we compress that entire data frame into single column. This is a single column, that's why it is series. And if we put unstack there, then it will do the reverse of unstack here. And for the stacking, it will again make multi-indexing. So even if we had not done it, for stacking it creates a multi-level series. So, and unstacking, if we are doing unstacking here and if we run it, we can see it will remain as a data frame, but it will unstack it. So long data frame, it will convert the long data frame into wide format. If we have to go by this thing, we can see So region wise it is like this, 12 rows will be there, then sales and cumulative sales as the columns we have added. Then for each product, for each date, the data will be like this. And if we see the type, then obviously it is a data frame because it has columns, 12 rows and 2499 columns. There are a few more advanced data frames which we are going to see, and there are two, pivot and pivot table. Yes, both are different. And in pivot it will reshape the data frame by specifying an index, column and values. And don't get confused with stack. Here it will be data frame only, it will not make it in a single column. So it will, we will have to specify index, column and values. And for pivot and pivot table, there is a difference. In pivot it will not handle duplicate entries, but in pivot table it will handle duplicate values based on and here we will use aggregation function as well. So let's create. So since our data frame has duplicate entries for date and product, so we are using df unique here and dropping duplicates of date and product. And so pivot df, if we see pivot df, here we can see index is date, so it is date, and then columns is product. So product is a column, a b c, these are the products, and values will be sales. So for particular date, for particular product, we date value will be here. And for an example of pivot df, pivot table df, sorry, table, we can see values we are taken as sales, index is date, columns is region, and aggregation function is np.sum. That will make sure the columns region east, west and all. So we will have sum. So here we can see for this particular date, for east, the sum of all the sales was 1698. So for all the three products a, b and c. So pivot df table is like this. And just like I said, type will be data frame for both of them. Then another few of the functions are there. This group by with transform is so in the last video we had seen group by. Here we are going to see how, if we want to create a column uh, using group by, and within that, and within the line we have to add it back to our original data frame. So here what we are doing, we are using df.group by, then we are using that column, and then we are using transform. Here we are transforming, we are using lambda function here. So here what it is doing, x is our sales upon sum of sum, x dot sum. So it will give us 0 point something, so the ratio will be there. So sales ratio is there, so 837 of total for that region sales. So this brought 0.00608 like that. The group by function will group by a data on a key or multiple keys based on how we pass it, how on is equal to and all, and apply the transformation and aggregation. So here we are transforming and putting aggregation here. So transformation, what we will do, it will give the same shape as intended. So that's why we can add a column. Now if we want to add multiple aggregation functions, we can do it like this: tf.group by region, then dot aggregate, then sales, sum, mean, max. So here we have put 4. You can put anything else. And if we see group data frame, group data frame object, grouped object, here we can see for sales, for each region it is sum is this, minimum mean value is this, minimum is 100, maximum is 999. Then another function, there are window functions which we can use. Here we are using rolling cells. So rolling function is there. So rolling function, what it will do, it will create a rolling of window size 3. So last 3 rows, it will create a window of size 3. And so that means our rolling sum will be there, since we are using sum here, and it will calculate rolling sum of previous n rows, that is 3 rows. So if we put here, you can see 837 28 sorry Sales is here, so this sum we could see cumulative sums is 2058, and we have started 3, so the sum will be 2158. Now what it will do, here it will do the sum of these 3 rows, and these 3 rows sum will be like this, then these 3 rows sum will be like this. So rolling sales will be doing on based on windowing. So here it is a window function, so first it will create a window function of 3 size, then it will create rolling sum. Then another functions here are lambda functions, and just like in Python, the lambda function here we are doing in Pandas. The syntax is we are writing apply, and in applying we are writing that function. If you write a custom function, even that you can apply here. You just have to call that. So here lambda function, in lambda function the input will be x, that is sales value, yes if x is greater than 500, else no. So if the sale value is greater than 500, it will return as yes, and that will assign in high sales, otherwise no. Then there are string operations which we had seen, and one of them is string extract. So string extract will do use regex pattern. Here what we are doing, we are getting product code from product, and here even if our product is a single line, so this is just for an example, this is just a single character, and in product str.extract what we are doing, we are assuming it is a single character. So we are taking uh, first value which is capital from A to Z, and first character we are getting and storing it in dproduct.producted. So that's how we can use string.extract here. If we suppose from A for apple it would have been, then product code would be A here based on our logic whatever I have written. And the query operation, so the last function is query, where logically we, if we want to divide a data frame, we want to filter a rows, filter the data frames. So here in df.queries we put sales as a column, and the value will be greater than 700. So this will give us only those rows which having sales values greater than 700. So these are the advanced data frame in data frame operations in pandas, and that's how we can work on it. So if anything else is there, please put in comments.